Your break. Unfortunately, I got called away tonight, so this will just be recorded. I'll see you Thursday. But we're into the muscle system itself. And so we're talking about the skeletal muscle system. Muscle tissue consists of all those contractile tissues we talked about just before the break: skeletal, cardiac, and smooth. But here we're going to focus on skeletal muscles, looking at how the muscles interact to bring about movement, the criteria for naming muscles, the principles of leverage, and I'm going to provide you lectures for those. And then we're going to review the major muscles of the body. I am not going to try to lecture you on each one of them, but I will put up some things to help you. And most of your homework, which you will not have to watch videos to do, is going to be based on those muscle groups. Anyway, let's get started. So muscles can only pull. I've told you that before. They don't push. There is one muscle group that does something. There will be another muscle group that can undo that movement. So there are three main functional groups: the prime mover and its agonists. They have the major responsibility for producing a specific movement. So remember, when we talk about these functional groups, we're talking about specific movements. The antagonist would be opposing or reversing particular movements. Prime movers and antagonists are usually located on opposite sides of the joint across which they act. And then there are synergists that help the prime movers. They add extra force to the same movement, or they reduce undesirable or unnecessary movements. Type of synergist could also be a fixator, which immobilizes the bone or the muscle's origin rather than enhancing the movement of the prime mover. Excuse me. These are going to give the prime movers a stable base on which to act. So we can infer from the position of the muscle relative to the joint it crosses. We can give you some examples in the shoulder joint, what kind of movement it would do based on where it is. So if it's on the anterior side of the joint, it's going to produce flexion. Posterior side would induce extension, just because of their positioning. Lateral side will do abduction, and medial side adduction. So functionally grouped, same muscle may be a prime mover in one movement, an antagonist for a different movement, and a synergist in a third movement. So again, these terms are about the movement, not about the muscle as an isolated thing. How do we name muscles? Muscles are named based on their location, bone or body region which the muscle is associated with. For example, the temporalis muscle is over the temporal bone. So these conventions for naming muscles are very important. We run into the same things we run into before. They are very descriptive, very specific, and they do give you a lot of information, but they're in a language we're not used to using. So once you learn what these terms mean, when you hear deltoid muscle, you'll know a great deal about that muscle. And deltoid muscle is one of those muscles that's named for its shape. Deltoid is triangle in Greek. We also add the size of the muscle to muscle names. So many muscles will have a maximus, minimus, and longus. We can name them based on the direction the muscle fibers or fascicles run. So a rectus muscle, the fibers are going to run straight. Transverse, they'll run at right angles. And oblique, they'll run at angles to an imaginary defined axis. Some muscles have the number of origins in their name. So the bicep would have 2 origins, tricep would have 3 origins. We can name them for the location of the attachments. They'd be named according to a point of origin and insertion, origin being coming first. So a good example of that is the sternocleidoid mastoid, which attaches to the sternum, the clavicle, inserts on the mastoid. muscle action for the action they produced, a flexor or extensor, particularly in the arms and the leg. And we usually combine several of these. So the extensor carpi radialis longus extends the wrist using the radius, and it's the longest one of them. Its length is long. All right, so now we'll talk about fascicle arrangements. All the skeletal muscles consist of bundles of fibers we call fascicles. We talked about that before. We had a similar structure in nerves. Those fascicle arrangements will vary, resulting in muscles with different shapes and different functional capabilities. The common ones are going to be circular, convergent, parallel, pennate. And we have examples of each of those. Convergent, pectoralis major; circular, the orbicularis oris around the mouth. Parallel and pennate is actually a term that means feathers. And so we have multipennate, bipennate, or unipennate. So the circular fascicles are arranged in concentric rings. Again, those muscles around your lips, the orbicularis oris, are organized in a circular way. In a convergent muscle, we have a broad origin, and the fascicles converge toward a single tendon insertion, again, pectoralis major. In parallel, the fascicles run parallel to a long axis. They form strap-like muscles. The sartorius muscle is a good example of that. A fusiform is a spindle-shaped muscle. And we talked about smooth muscles. We said those were spindle-shaped. That's wider in the middle and narrow on each end. Biceps brachii would be a good example of a fusiform muscle. Pennate, again, pennate refers to the same word that means feathers, so they're kind of feathered off in a direction. And they have their fascicles attach obliquely to a central tendon running the length of the muscle. There are three major forms of them: unipennate, bipennate, and multipennate. In the unipennate, the fascicles attach to only one side of the tendon, or extensor digitorum longus would be an example of that. In a bipennate, the fascicles would insert from opposite sides of the tendon. The rectus femoris was an example of that. And in a multipennate, they appear as feathers inserting into one tendon, and the deltoid muscle is a good example of that. So here you can almost see them as a pile of feathers in the deltoid. In a bipennate, we've got one here and one here. And the unipennate, they all come off one side of the tendon. Most common patterns, again, are circular, convergent, parallel, fusiform, and pennate. And those fascicles are going to determine the range of motion, which would be the amount of movement when the muscle shortens. The fascicles also determine a muscle's power. Long fibers, more parallel to a long axis, shorten more, and are usually not that powerful. Power is going to depend on the number of muscle fibers. So bipennate, multipennate muscles have the most fibers. They don't shorten as much, but they are very powerful. And I'm going to stop there and handle lever systems on its own. Hate to throw physics into all of that nice anatomy and physiology, but we do have to.